today is Mike Jones, the CEO of Delta Gold Technologies, after the company announced a research sponsorship and exclusive technology licensing agreement with Penn State University in Pennsylvania. Nice to be speaking to you again, Mike. How are things?
Great to be back. Outstanding. Going very busy, but we're going.
Good. So this is another university then that you're partnering with here. I think, is it going to be for about $1 million US? Is going to be the total money that's going to be sort of given to this program here. Just tell us a little bit about the program first of all, why you've partnered with the university.
Yeah. So the partnership is $1 million a year. It's a three-year program, very similar to the one we have at University of Toronto. So we have two universities now in two countries. The amazing thing is that completely independently, Penn State was actually working on gold as a material for quantum computing. So I think for investors, that's the headline, is two universities completely independently found this material very interesting for development of a qubit, the fundamental engine of a quantum computer. And so we, of course, found out about this and basically turned a threat into an opportunity by sweeping them into the program. And actually, there are collaboration opportunities between the two universities. Obviously, they were working with similar ideas, but not exactly the same on the same material. So we now have two physics professors in quantum actually working on materials involving gold. So I think it's a big indication, and it's a step towards what we see as our mission is a center of excellence in the world. And we're looking at other things currently as well.
Well, you've sort of got the best two in the business, right? And I think it must give you some sort of internal, credibility, validation that, yes, someone else is actually looking at this as well, yeah?
Yeah, and they actually came at it from a slightly different perspective. So there's a published paper on the Penn State work about nano clusters of gold. So actually taking nanoparticles in clusters and how you deal with those clusters in a different form than we're looking at University of Toronto. But it's the fundamental physics of where gold sits on the periodic table and how it behaves that are core to both of these two universities' work. And it's very satisfying to see two great physicists working in parallel positions and unbeknownst to each other, actually. And we're able to bring them together. And I think this is a thesis for the company, really, is developing academic relationships at the very top of the game and actually creating collaboration across those potentials. And it's very, very along the lines of what's being just newly assembled now, the National Quantum Center here in the UK, just outside of Oxford. And I visited there, actually. That was a huge eye-opener as to the serious effort that the UK government is making in quantum as well.
Well, tell us a little bit about that. It sounds like it's probably a very futuristic thing to have sort of witnessed.
That's a good word for it, futuristic. I mean, the first thing is the Rutherford Appleton Science Center is something that I encourage people to research. I mean, it is, something like 15 Twickenhams. Let's put it into perspective. And it does everything from lasers to neutron science to nuclear science. So there are buildings the size of rugby fields all over the place with scientists working on all kinds of things. You're literally talking about billions and billions of pounds being invested in science and being at the front edge of innovation. So I think that's news for people in the first place. And then in quantum, there's a brand new quantum computing center, which has the mission to actually draw together companies, people, and be a bit of a validator and an assistance to the whole community. So there's quite a leadership position there. And we actually saw active laboratories doing everything from traditional quantum computing qubit work to trapped ions using lasers. I mean, it's really, to be perfectly honest with you, it's a bit beyond Star Wars, really, to see it. Like it definitely expands your mind into where the frontier of science is and the amount of effort going into quantum. I think quantum is a very unappreciated thing of how serious this effort is. It's tens of billions of pounds a year with thousands of people working on it. So I think people have to recognize this is coming and happening as a very big industry.
Excellent. Good to hear that. Just coming back to the main bit of news here, you've talked about this centre of excellence, which I'm guessing is going to be effectively Delta Gold. You're going to be that sort of centre, if you like, bringing things together, as you've said just now, in Penn State and Toronto. How are you going to sort of split working with the two? I mean, you sort of introduced them and they're going to work together, or they're going to go their separate ways, they've got separate funding. How's it going to work, do you think, with the three parties now?
Yeah, so we're at the center of the thing. We're providing the funding to both of them. They're kind of working in silos at the moment, where they've got their own scope of work, their own budget, and their own research teams. So you'll have postdoctoral fellows who are attracted to each one of the universities working in labs. So at University of Toronto, we have about 15 people there working on our project now. We'll probably scale Penn State up to a similar sort of level. Okay. And so you'll have two labs working independently on slightly separate approaches and problems. However, over the next few months, as that science develops, they will have as a resource the other physicists working on the same element. And so some of that physics actually, of course, overlaps. And what we anticipate is going to happen, and there's some other work that's going on in this regard, where top physicists will actually say, well, actually, here's an area where our science and our expertise actually overlap. And there's potential valuable intellectual property in that overlap. And personally, that's where I think the greatest potential for discovery is actually in the unique combination of the experience and the lab potential and the postdoc teams. And when they combine their ideas together, I think this is where the greatest discovery comes from. And actually, I have an unusual analogy to this that I've experienced. Just a very quick story. So as many people would know who know me, I've worked in mining for a long time. And I asked the top professors in the world about platinum, what their exploration ideas were. And I was sure they'd been asked many, many times because they were the top professors in the field. And to my shock and amazement, all 19 of them that I talked to had never been asked. No one had ever asked an academic where to look for a platinum deposit. So long story short, I put 19 of them together in a room for months. They argued like little school children, and they finally came up with a list. And that list was 85 ideas. And number 4 on that list is now the Waterberg deposit that's worth $20 billion. So when you put great academic minds together and ask them questions that nobody's asked them before, very interesting things can happen. That's in my personal business experience. So part of the idea of Delta Gold and the Center of Excellence and actually asking academic people for truly commercial intellectual property ideas, that's in the core of nature of things I've done before. And in this case, you can feel it. It's exactly the same pull. Immediately, the professors say, this is very interesting, and yes, I'd like to work together on that.
Excellent. Good stuff. Well, it sounds like there's lots going on in the background. And the end goal, as you say, is really to get some valuable IP. But of course, anything can come out of the collaboration, right? And anything can happen during that whole process. So I'm sure you'll be keeping us updated as things go on. Anything we can sort of look out for?
Well, certainly initial applications for protection of our intellectual property, I think, is one of the big milestones that investors should see this year. But also, we're not done with collaborations yet, so stay tuned. That's a very active space, and I think putting a global center of excellence together will be something that people will really start to recognize, and this is just the first step in that regard.
Well, Mike Jones, the CEO of Delta Gold Technologies, thank you for joining us today.
Thanks for your time. Thanks for watching.
If you enjoyed this interview, then give us a thumbs up, a like or a retweet. Subscribe to us on YouTube or follow us on Twitter and hit that notification bell to be the first to know when we release new content. There's loads of great content on our website too, across all our programs at stopboxmedia.com. Thank you for watching.